to. Okay, so thank you for pointing this out. So now hopefully everybody can see what we're up to. And right now we're just fixing our code from last time. And the thing that we just fixed is the camera tracking. So now we jump and there's no jerkiness in the camera motion, just tracks us very smoothly. And then we go left and right. We just, we're going to try to do any fancy tracking because that was kind of jerky and there is no reason to do it. We just always want to be in the middle of the screen. So I think that's done. So we don't need target X, just CX. And let's see, what's this target? The CX is this, there's no target, CX. But we do have, we're going to have a constant for how quickly, the camera follows the player, basically. So let's go with like cam track weight, and this is the 5%. So 5%, and 0.95 is nothing but 1 minus that. All right, so still working, great. Okay, so we can cross another thing of our list. Just double checking. Okay, looks like we're still streaming with a shared screen. Okay, so camera done. Okay, collision. All right, this is going to be interesting because I don't quite know where we have our bugs, but we can go step by step and figure it out. Okay, so thing number one is faster X speed. So let's say our speed X is 3, right? So now we can run really fast, but you'll notice that we run into the wall, right? And we don't want to do that. Thankfully, we basically already have the code to fix that. It's the same thing as when we are falling down. We want to see if we were to move with our velocity, right? So it's this graph right here. If we were to move down, let's say 3 pixels, would we collide? And if we do, then we kind of use this trick where we move just enough to be on top of the support structure, the block, and we know that it's always aligned to this 8-pixel grid. And the same thing, when we're moving left and right, we can just snap to that grid. And it's basically going to work as long as you don't move, I think, more than like 7 or 8 pixels in any given frame, which I don't think we will. And if we ever get there, then we can fix it at that time. Okay, so speed x equals 3. So put this up and think through how the collision code should work. So here's the player, right? So it's a square. This is our EXPY. right here. Write it down, px, py. And the square is 8 pixels long. So let's draw a few of these lines to kind of show these are pixels. And guess I want to show that there are also pixels. I guess let's use black for the player box. So here we are. So there is these are like pixel lines. Like this. 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 Oh, it's getting a little messy. Okay, what am I trying to do here? I'm trying to kind of double check how the collision works. So let's just go to the collision code and walk through it, and then you can actually make a helpful diagram. So, okay, process collisions. So here we process the collision when we move left to right. And then there is kind of this interesting thing where, like, do we want to process the collision when we move left to right first, or do we want to move it? Do we kind of want to process it? We want to process the collision when we move up and down. And it actually does make a difference, I think, in some edge cases. I don't think it matters for us too much right now. It is a platformer game, but it's not about kind of hardcore platforming where it actually really matters like every frame and like you have to pixel perfect. So if our code is a little off, it shouldn't make a huge difference, I think, to the player experience. If it does, we can revisit it. But for now, it's going to be okay. So what we're doing with when we're moving down is now we have this function called collision down, and I like that. So let's kind of use this template, so to speak. So we'll have collision left and collision right. So let's do that. So if Ex is greater than 0, then we want to do like this. If collision right with our velocity, then something happens. And what happens? Well, a few things might happen here. So right now in our collision code, we're processing both the collision with the ground, like a block, and we're processing a pickup. Now, I'm wondering if it makes sense to kind of separate those out. Ay, ay, ay. probably, well, hard to say for certain. Like, are we ever going to use, let's say, collision right code where we don't also want to, pick up, do a pickup? I can't think of a case right now. So let's just assume that we're going to process both at the same time. So collision right will return true if we are blocked. And if we're blocked, then all we have to do is set Vx equals to 0. And just like we do here, we round up our x position to the nearest 8 pixels. And that way we are going to be like on the grid, and we know we're not going to be inside wherever we just hit. Because we haven't moved yet. Okay. And similarly, if Vx is less than 0, we're going to check collision left and do the same thing, except here instead of how it's called F. Okay, so floor is the opposite of ceiling. We're rounding down. Okay, so now let's move this out of here and create our collision right, collision left function. Collision right, given our velocity for this. Okay, so collision right, we know that so we're not using Vx anymore, we're using PVX, but we know it's greater than 0. So we know that this is true. Like this part. Oh, but let me copy this also because we are going to use similar code for collision left. Okay. Now we can change it here. Okay, so for example, this is kind of the thing that I want to make sure that we're getting exactly right. There is no off by 1 errors. So Px is 0, and that 0 is kind of pointing us to this line right here, right? So that's 0. Px plus 8 should point us to this red line, so just outside of our player box, the black player box. Okay, that checks out. And similarly, let's use is yellow gonna show up? Kinda. Yeah, I think it's fine. So 0, and then 8 will be of the next go down. Okay, so when we're going to the right for the top collision, we want to check that we want to check this pixel right here, and that's px plus 8, but on the same y coordinate as the player. So the map file is red x divided by 8, red y divided by 8. That's right. And then we get the collision flag, set it to block, and here we're not processing block, we're just going to return it. And then, but we do process pickup. So we check if there's a pickup, and if there's a pickup, we do pickup. Okay, that's fine. So now bottom collision. So actually the thing we need to do right now is to account PVX. So let's see, how do we do it in our collision down? We do +8 plus PVY. So +8 plus PVX. I feel like that's not right. Like if PVX is 1, right, in kind of our original case, then now we're not checking the next pixel. We're actually checking 2 pixels over. This needs to be 7. If you're hearing some background noises, that's just my 7-year-old expressing herself. 7-year-old, 7-month-old expressing herself. Okay, so px plus 7 gives us the last pixel that's still within our character frame, character sprite. But then, let's say if our velocity is 1, we go 1 pixel out. Now we're outside, 2 pixels out, so on and so on, depending on the velocity. Okay, so PVX is greater than 0. So bottom collision is still like this, +7 plus PVX. But we're checking the bottom part, so +7. So not +8, because +8 would put us outside of kind of where we are, and right now we're just moving to the right. So +7 is still within our boundary box. So block. So we don't need to do the bottom collision if we already blocked. So if not block, then we gotta do all of this. Because if we're already blocked, we're already not moving. Doesn't matter. But we are going to check the pickup. Oh, but the pickup relies on MXMY. So we actually need to compute that anyway. So it's just this part. So if we're not blocked, then we have to check if we can be blocked. If we're already blocked, doesn't matter. And we check the pickup and return block. Okay. Basically it. Actually, instead of editing that old code, I think it'll be easier to just edit this new code because that's much closer to what we're actually going to do. So collision left, same thing, but so PVX, we will have the sign, so it might be like, let's say, -1 or -3. So this part, PX plus 7, this needs to be just PX. And same here. I think that's the only difference. So PX gives us the pixel, the leftmost pixel that's within our right. So if PVX, let's say, is -1, then PX -1 gives us 1 pixel to the left of our right. That's the thing we want to check. Return block. Okay, I think this should work. So let's try it out. Let's see. Dun, 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 dun. Dun, dun. Okay. Great. So I'm moving left and right pretty fast. I'm not intersecting with the right wall. Whoa, whoa. Okay, well, something happened there. Oh, interesting. Something's happening. Some kind of bug is still present. Okay, but at least when I'm running, doesn't look like. Oh, and I just fell off the map. Okay. Okay, so somehow when we're jumping, we were able to go into the stone. I wonder if it's because we don't do the top collision. Like we're kind of jumping into it from the top. Doesn't make sense. Something is weird here. Hmm. Hmm. Might be. It might be an issue with our Y collision. Is it? No, like the Y collision just moves us up and down, right? And this is not an issue with moving up and down. This is an issue of us actually moving left and running into the wall when we shouldn't be able to. So it's definitely an issue with our X position. Okay, let's go step by step, right? So pretend we're a computer, go step by step, see what's going on. So in the beginning of every frame, we're going to set our velocity to 0. We're scrolling to see if I can refactor things a little bit to make things a bit more readable. If false, do not. Oh, okay, this is like some old code. We don't even need this. Okay. So all of this, most of this, is about moving. So let's refactor it out. So update player move. Very wordy about just move player. And this part as well. Okay, so Vx is 0, right? So in the beginning, let's see here, move player. So in the beginning of every frame, we're not moving left or right. We do preserve our y velocity, then it's affected by gravity, and then clamped to make sure we're not falling too fast. Okay. So if we're not in build mode, then we can move ourselves, and this is when we change Vx to either be, let's say, +3 or -3, right? So speed x is 3. Okay. If button up, then we jump. Okay, so that's not what we're looking at right now. Okay, process collisions. So if Vx is greater than 0, we're moving to the right. We do collision to the right. And if we have collided, then we set Vx equal to 0. And we kind of clamp our position to the nearest map cell. And I don't think there is a problem with clamping. I think if there was a problem with clamping, we would kind of just see ourselves like move too fast to the left. Oh, what is happening with the jump right now? Did I break it somehow? Like way super high. Oh, see, I changed the order. So here, it used to be that I applied jump. I modified the velocity by applying jump strength. And then I factor in the gravity, but now I'm factoring the gravity and then applying jump strength. So just for consistency with the old code for now, let's keep it there. Okay, so back to our old jump. Right, so right here I jumped into it, but I wasn't like clamped to any, like I wasn't clamped to anything, so it's not an issue with the clamping. Like I'm moving left, right? So it would be, if there was an issue, it would be because we would just maybe like it would like clamp us into the block. That's not what's happening. So okay, so we know it's in collision left. Let's see what can it be here. Vy. Yeah, this variable doesn't quite make sense. Red x, red y. It's from this picture. There's this red dot to kind of help us determine where the collision should happen. Okay, let's think. Px plus pvx. That's like px minus 3. Or here, let's see just one, right? Just one pixel at a time. Lock the screen. Okay, so even just one pixel at a time. Oh, okay. Well, so this makes sense, right? So we just somehow right now snug into the block, and if we go left, then it collapses because it thinks that we're moving left, we hit something, so we need to be, clamped to the grid, and it clamps us to that grid, which is the correct move because we shouldn't have been able to get into this block anyway. Interesting. So even with one pixel, we still have the bug. It's not even because, and I mean, we had it last time too before we modified player X speed. So that's not too surprising. Yeah. Yeah. Mm-hmm. So the survey says, can it be that you're moving diagonally through the corner of the block? So there's no X collision and no Y collision separately detected during the processing, but after you modify X and Y, you're inside the block. That's an interesting point, actually. You might be right. So we don't move diagonally because we're processing our kind of left-right move by itself and then up and down move by itself. So we'll never kind of, it's not that we can't do both at once, but the collision is done separately. But you're right that what could happen is, I'm trying to think through it. Where um, let's see, what is the order in which we move? We move left, and then we uh, oh no, you're right. You're right. You're totally right. Yep, I think that's it. You got it. You got it. Very cool. So this is the bug, right? We check if we can go left, and if we can, we don't modify our Vx, and then we check if we can go, let's say, like down, and um, if we can, we don't modify Vy, and then we move ourselves. So indeed, if we have um, Vx and Vy, we're essentially moving diagonally. So Pretty simple fix. We process our X collision, and then we actually move, and then we process our Y collision. Great call. Great call. Yep, and yep, sure enough, can't get into that block anymore. Woo! Nice find. Nice find. Okay, so let's go back to faster speed. Let's check everything is okay. Kind of like run. Actually, it's pretty funny. We can kind of run across the gap. We're that's funny because we were moving like 3 pixels at a time. So we actually can't even align ourselves with the hole to fall onto it. I don't know if that's an issue really. I think it's okay for now. Oh, they're back there. Oh yeah, it's just kind of when we go up through the roof. Oh yeah, so this is like a small bug when we jump down on something because we only check pickup on left and right move. Let's all right. So let me check collision right, collision left. Okay, great. So we did the first part. So we allowed for faster X speed. So now we need to do collision upwards and pickup. Let's do the pickup first. Should be pretty easy. Gonna be just like this. So pickup, we're gonna get the pickup flag, MX and Y, do the pickup, and the pickup here. And this should be a 7. It should be a 7. Are we using this? Lighting. Oh, this is how we do this here. Okay. So for consistency, let's do it the way we're doing it in the X part. So if not block, then we need to check if we can be blocked. And then we don't need this part. Block. Okay, so this is a collision down. So just checking. Still okay. All right. And now we need to do collision up. So here, if By is less than 0, then collision up. I don't think we need this comment anymore. It's pretty clear. So if we hit the ceiling, what do we want to do? We just want to do this now. And so something fancy you can try to do is you can kind of say, well, you're going up, you're hitting the block, so you should kind of bounce down. And so you can calculate maybe how far down you should bounce. And we'll see, maybe we will need to do it, but for now, let's just process it in the same way we process other collisions. So, collision, right, collision, copy all of this, collision up. So left collision, same x-axis, but this is just py, and right collision, this is just py. And I think that's it. So let's see how this works. So, oh, sure enough, I'm jumping up here, can't jump through this anymore. I feel like I'm hitting, oh, interesting, I can't jump right now. Oh, I think there might be a bug with our jump checking code. Yeah, what's happening there? So right now I can't jump. Interesting. Okay, so I think this part is done. Collision upwards and pick up. Oh, let's check the pickup. So if we jump on a crystal, we get it. Let's put a crystal within a jump reach somewhere, like right here. Should be able to jump. Yep. So we can get it on a jump. We get it when we land. It wasn't quite the landing. Great. So that part is done, but I think we found a bug with jump. So let's go check that code. Let's see, where are we here? Right here. Okay, so if button up, then we check collision down, and if it passes, then we jump. Okay, so my guess is that collision down for some reason doesn't return true. We give it 1. Collision down with parameter 1. Down with parameter 1. Okay, so why won't we return block? Here, not block. Block is collision flag, PICO. Hmm. Hmm. So here it's not an issue. And jump. So when I'm kind of off on the right side, then jump okay. Or if I'm off on the left side, oh, well, hold on, that's not quite true either. I can jump here, here is fine. But here I can't jump. wow, so strange. Oh, no. Well, I'm thinking maybe I am jumping. Um, but then I'm like hitting the top immediately somehow. So let's see what happens when we jump. Move player, Vx equals 0. So we set our Vy and we modify it. Then we process collisions. Oh, so okay, so one thing I said is we should never ideally move faster than about 7 or 8 pixels per frame to avoid any funky collision issues. And I think, let's see, where's the jump strength? Probably be under player. Well, I can see what's here kind of with gravity. Yeah, so jump strength is 18. Then we modify it by gravity. That gives us 13. So in the first frame, we're moving up 13 pixels. That's not good. I think that's what happens. We're actually, yeah, we can jump here, but here we're like on the very first frame, we hit the block that's above us. And then what happens? Um, let's see, so collision up, we set, right, we set the velocity to 0, and then we basically leave the plate, well, we clamp down, yeah, we round our Y position to the nearest 8 pixels, but we're already at an 8 pixel boundary because we're just standing on the ground. So we actually just don't move. So, okay, so we found the bug. What do we want to do? Guess two things we can do. One is make our jump not as strong, maybe. Let's try that. One thing we can do maybe is kind of do this part. So first we're modifying Vy by gravity, and then we're applying jump strength. So now jump strength doesn't have to be as strong. Let's make it 10. Still a bug. Let's make it 8. Okay, so now not an issue. And but also so let's make the gravity a little weaker. Just trying to see if there's some parameters here that will give us acceptable behavior, and then we don't have to change our code very much. Okay, it looks like we found it. So we can still jump on the kind of 2 blocks. So something that's 2 blocks high. I think, yeah, can't jump something that's 3 blocks high, and there's no bug here. So I'm going to call it close enough. And we can just move on with our lives. Great. So fix the jump. Okay, two more things to do. Okay, it's 11:40. Okay, pretty sure we can fix the build buttons. Power transmission might have to wait um, until later today. But let's see how fast we can get there. Okay, build buttons. So I thought about it, and I think what I want to do is to just use down to change the build. And then the secondary button is just always build. And I think that'll make things clear. And because our build just kind of so happened, but I think it's actually pretty nice that our build icon is on the right. When we press down, we can actually kind of pop up a little menu that goes down from the build icon, and we can show all the things you can build. So as you press down, you're kind of cycling through that menu. Yeah, that's something we can figure out later, but for now, let's do that. And one of the big wins that I want from that is so right now, like if I move and build, there's this kind of staggering thing. And it's because I'm entering the build mode, right? Build mode. And then I'm not moving when I'm in a build mode. So that just seems like way too clunky. So let's get rid of that. There's no build mode anymore. We can build anytime, any place, any quadrant. And here, so X is our build. So what I want to do, let's see, process. Basically, I want to say if button down, then yeah, and then we just change our build I. That's it. That's all I want. And let's see here. None of this. Don't need any of this. Wow, so much simpler. We just build. We just build. So building, 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 building. Wow, so much easier and fast. Wow, it's beautiful. And then down, up should be the button P, right? So difference button returns true every frame that the key is pressed. Button P works more like kind of a standard typing keyboard. So um, just returns true every so often. Wow, so much simpler. And I can build anything, anywhere. Wow, that's great. Wow, this feels really nice. I like it. Okay. Um, did we have this building code anywhere else? I think there was just there. Oh, we had this. What is it? If if in build mode, kind of highlighted that thing. Don't need to do it now. I'm gonna mark the sprite as not used anymore. So not using this one. And I think that's it. So we can change our build item and we can just build much easier. Great. To build. Oh, this maybe should be button P. Doesn't have the same kind of smooth feeling where I can just like screen fill everything with the building. But probably okay for now. Like one thing we would probably check. Like my guess is that we're gonna go back to just using button here, so it will be easier to like screen fill something with buildings. But what we will need to do in that case is check, like, have we built something in that place already? And if we have, then don't build it. Actually, well, we can just do it right now. So this is what we're here to do. Let's see, do build. So if s is 0, then we set it. That's it. That's it. Then we set it, and that's when we charge. That costs crystals, because then we're actually building. So oh, sorry, that's not the s I wanted. It should be get max on y. Then if s 0, then we want to do this. We want to get the sprite from our build table. That's the sprite we're building. Take a crystal away and set the map. So great, I can still build it super fast, but now you can see, like, so I'm building right now and moving. It's not charging me anything, but then when I jump up here, oh, it charged me 1 crystal for building that one thing. Great. And then we'll probably have a tool later, that like deletes the thing that you built. So you can undo the buildings. Okay, well, we have about 15 minutes, and the last thing I wanted to do was power transmission. So one scenario that I kind of have to consider is, let's say we have something like this, right? We have the power source, and now we built these things to conduct the power. And now, we go back to this one and we delete it. So what will happen right now is everything will retain its power, because the way it's kind of structured, when the relay is on, it's also marked as generating power. So it kind of becomes self-sustaining, which is maybe interesting. Like maybe that's what we want. Probably not, though. So an interesting thing would be, like, if you allow for that, is you have your power source, you build a relay is charged. You build another relay, that relay is charged. Then you can delete the first relay and maybe you get like resources back. The second relay is still charged. Then you build one next to it. Now that's charged, you delete the first one. So you kind of leapfrog. So with only 2 relays, you can kind of move the power to anywhere, which is kind of an interesting mechanic. Like, I'm going to talk a lot more about this, later today when we actually do more of the game development. But I kind of want to have some puzzle elements in this game. And I think this is actually like a very interesting puzzle element that could be fun to play with. Like in the beginning, you just have very limited relays, so you kind of have to use them in this funny way, like you charge them. Oh, no, that's right. Yeah, no, that's right. Yeah. And I was going to say, like, if we can't do, like, so let's say we don't want that, then the thing that would need to happen is somehow we would need to decide that for this group, they're no longer connected to a power source. And that part would be a little tricky, right? So yeah, another thing to keep in mind right now is we are like this part of our code right now that goes through the entire map is too slow right now, right? So let's come and bring it back. Yeah, like you can see how choppy everything is. So every fourth frame, we just have this very expensive thing. So we don't want to go through every cell on the map. We only want to go through cells that actually are, either they have power or they're powerable. So let's have a table for this. Let's see, build table, names, and then we have where the powerables sort of thing. Powerables, powerables, power things. I don't know. Let's call it powerables, and then we're gonna make powerables. So make powerables is gonna be kind of similar to this. Make animations. We're going to go through. We're going to go through every cell on the map. Gonna get the sprite, and then here we're going to check, is basically a powerable, and it's a powerable if it has one of these two flags, the power source. Well, actually, no, we don't do anything with power sources. No, it's literally just this one, just powerable. So if it's powerable, then we're gonna add it to our powerables and mx and y, and then I don't think we need anything else. Okay. And then here, now we don't need to go through the entire map. We just go through for, let's see, powerable in all powerables. And max is x, max, and then y is my. That's it. That's it. Let's see. I think it's this one. Get the sprite. Is it powerable? Actually, we know that it's powerable, so we don't even need to get this part. We already know it's powerable. So we just need to check that it doesn't have power. And we turn it on. And there is no turning things off right now. So that's fine. What just happened? What just happened? What? That's so funny. What is happening? Things right next to the power source. Okay. Yeah. It's like spreading the power somehow. It's so funny. Okay, what did we break? Okay, so powerables, I think that's done right. So it found our, power source on the map. Or no, wait a minute. Wait a minute. Wait a minute. Wait a minute. This is a power source. It's not powerable. So actually, we shouldn't have any powerables right now. Only powerables. Let me just double check. Powerables. That's flag 3, right? That's this green flag. The only thing that has this green flag is the relay. Well, yeah, the relays. So make powerables. Oh, here's the problem. Fget should have this. Okay, that was kind of funny. That's a funny bug. Okay, let's try it out. So build. Right. So yeah. So one thing I had it in the back of my mind, but now we can see it. So yeah, it's not transmitting power because when we build a powerable, we now have to add it to this table. So when we do build, if get the flag of the sprite, does it have the powerable flag? If it does, then you know, then we add it to our table. MX, MY. Okay. All right. Let's build something here that's not connected to the power yet. So right. And then let's see this, and this. Awesome. So, okay, so now it's running pretty fast and it's not slowing down our game, and we are happy. At least until maybe in the, end game, there is so many power sources and things everywhere that it does slow down the game. But then, when we get there, we get there. It's a good problem to have. Too much power, too much power. But there's still this issue of it spreading maybe too much power at any given time. So what I want to do is, so here when we check neighbors and we say like, oh, okay, neighbor has power, we immediately set the right. And that makes, the next check for the next neighbor potentially also have the power and kind of has this cascading thing. So we're just basically going to delay it. So we're going to have this add power table. We're going to uh, add power to this table. We're going to add this a max y and the sprite. And then at the end of it all, once we've updated things that should have power, then we actually will go through that list and set the sprite. So basically, we're going to look at all the powerable things, look at all the neighbors, determine which neighbors should now have power, and then modify the sprite. And by modifying the sprite after we process all the neighbors, we're kind of guaranteed to only go one new neighbor at a time. Okay, let's run it. So build. Okay, so now let's see. It should cascade smoothly. Oh, what happened? Something's happening. Whoa. Whoa, 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 whoa. I like the bugs that this has. Like cycling through all the sprites, and it's like this contagious virus keeps spreading. Okay, something didn't work there. Max y is +1. Oh, not +1. We already counted +1. So let's try this again. And yeah, let's put some things here. Oh, I fell into the hole. The hole is now fallable onto the hole. Oh, okay. No. Okay, come on. Let's do it. Let's do it. Oh, yes. That is beautiful. That is super beautiful. I like that. All right. So we can build and connect. Let's see, how many of these can we build before the game slows down? So it feels maybe a little slow right now, but not too slow. Okay, not too bad. We're still running pretty smoothly, so shouldn't be a problem anytime soon. Okay, so that is done. Our to-do list is complete. Thank you again, the survey for helping with the bug. And I'll be back in about an hour and we can actually continue our game and uh, push forward. All right. Thank you, everybody.